Awesome. Welcome to another live stream. What I'm going to do in this live stream is cover conic sections for ellipses. So we have already covered talking about conic sections for parabolas, and now we're getting into ellipses. And we're kind of finishing off the end of the year. So I am going to kind of run into how to identify the ellipse as far as it being horizontal or vertical, how to identify the center, the vertices, the co-vertices, the foci, and as well as how to write the equation when given certain parts of an ellipse. So just a couple other things I just want to let you guys know about as we're kind of ending into the year. A couple things that I am, working on doing is, I have in my links down below, I do have some support groups on Facebook that I am looking into building up that, just to kind of help people out. I get a lot of questions obviously on YouTube that, students looking for some help and some resources. And so I have a lot of resources that I've been creating. I've been working a lot trying to create some step-by-step guides as well as some, kind of work that I'm going to be using in the classroom that I want to start sharing with you guys. So those are some things that I'm already starting to create, and I'm working a little bit more on during the summertime in preparation for next year. So if you are, in Algebra 2 or looking into taking pre-calculus, next year, make sure I would check out those, or going into Algebra 2, make sure you check out those two groups. Again, the description is or the links are in the description for those Facebook groups, and then I'll be sharing them up there. So after I am done with this live stream, I will be more than happy to kind of answer any questions that you guys may have. You can just kind of let me know in the chat, and then we'll kind of get into it. So before I go ahead and get started, I actually took my time a little bit. I got started a little bit earlier, even though it was a teaching day today for me. I did wanted to kind of write down the questions beforehand, so therefore we can kind of get through this real quickly. And it's not going to be a very long live stream. Hopefully we'll try to keep it like around 20 minutes and so on and so forth. So, hey Chris, hey Potato, how you guys doing today? Our ellipses on the ACT. You know what? I'm not really sure about the ACT. I do not believe that they have anything on ellipses for the ACT, but conic section is something that does come up in Algebra 2. It can come up in the pre-calculus curriculum, and really a lot of the form is, as far as a preparation into calculus, as far as cross sections and so on and so forth, as well as to kind of get the relationship of, the different cross sections for a cone, which we call, conic sections. So, but if you guys have any questions you want me to work on, I am going to get this live stream started, and I'm just going to go ahead and work right through the homework, and then I'll be more than happy to answer any of you guys' questions before we get off to the weekend. So, all right, and now, all right, see you later. Have a good weekend. So on this homework, we have, so first problem is x squared divided by 16 plus y squared divided by 7 equals 1. So there's a couple things that we need to know for doing this homework is the standard form of an ellipse. Now, the first two problems are actually the same type of ellipse. So the standard form for them is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, there's another form which I'll get into here in a second, which I'll do for number 45. But this form basically, kind of tells us what we're looking for as far as, in addition to our ellipse, as far as the center is going to be located at hk. Notice how the formula is x minus h, y minus k, but our center is going to be hk. And when we're looking at an ellipse, I'm going to go ahead and, when we're looking at ellipse, the distance, the couple things we need to remember, the distance from the center to the vertices is A, and the distance from the center to the co-vertices is B. And then last but not least, the distance from the center to your foci is going to be C, which we're going to I'll write down the equation when we get to it in these two problems. So the main important thing is we got to understand, well, why is a squared listed first? Well, a squared is always larger than b squared. And when you see when I draw my parabola, or at least in our notes, you remember that a squared is always going to be larger than b squared. So if we look at these two, we can, initially just kind of make our assumptions. And that's what I want my students, when we're looking at this problem, to basically immediately try to identify, first of all, what is the center? What is the center? What is your a squared? And what is your b squared? So let's just go and list this out. Let's just go and list them for these problems. All right, so for the first example, we notice that I'm not subtracting anything inside. There's not a quantity squared or a binomial squared. So therefore, I can say h and k are going to be 0. So I'm just going to write in the center is going to be at 0, 0. All right. And then the next one is, remember, a squared is always larger than b squared. So even if these were like moved around, whatever else, we can say that a squared is going to equal 16 and c squared is going to equal 7. Now, we need to find the value of a, so we're going to take the square root on both sides, and a in this case is going to be 4. Now, really, technically, it's like plus or minus 4, but we'll talk about that direction in a second. In this case, we're going to say c is going to be plus or minus 7, but I'm just going to rewrite this as 7, and we'll get back to that plus or minus. Now, to find, what am I doing, b? Where did that come from? C. That's not c, that's b. B squared is equal to 7, so therefore b equals 7. I think I just started talking about c, and I was like, well, we'll go with c. So let's look at the relationship between a squared, b squared, and c squared. Now, in Algebra 2, I spend a lot of time actually discussing, oh, I am an idiot. Why didn't nobody said anything? I'm teaching all this stuff, and nobody said. All right, so let's kind of maybe head back a little bit. I totally forgot. I guess that's like the problem with pushing that over there and on my one screen and not going to the other one. Okay, so sorry about that. When we're looking into, this needs to be over. When we're looking now, there we go. When we're looking into this, so here's my first equation, the x squared divided by 16 plus y squared over 7. Here's just the standard form of an ellipse where a squared is under x. And the reason why a squared is under x is because a squared is always larger than b squared. And what I was just getting into was in Algebra 2, I spent some time like investigating why, how a and b are related to one another. And in this class, I took my notes, I showed the students the graphs, and we kind of looked at the Desmos graph to kind of see how they performed. So obviously we're just doing some homework, so I'm just kind of reviewing this. I'm not getting in depth about ellipses, but those are some things you're going to want to remember, that a squared is always larger than b squared. The center here is hk, which in this case is 0, 0. So therefore a squared is 16, so a is 4. B squared is 7, so therefore b is equal to the square root of 7. All right, and now, can I move that down? Oh, I can't. That stinks. Okay, I'll have to change that. Now we look at our relationship with c squared. So the relationship with a, b, and c is going to be a squared minus b squared equals c squared. So to solve for c, I'm just going to take 16 minus 7 equals c squared. So therefore 9 equals c squared, and therefore c is equal to 3. Now again, that's like plus or minus, but we'll discuss that later. So now I know my values of a, b, and c. Let's go ahead and graph the ellipse, and then I identify what the values are, or what the foci, vertices, and the co-vertices are. So first thing, let's draw an xy axis. Okay, so in this one, we're going to have our center is at 0, 0. I'm just going to put a nice little C there for the center. Now again, we have since my a squared is under x, that means my major axis is going to be horizontal, and that's going to be along the x-axis. And a represents the distance from the center to your vertices. So to find my vertice, I'm literally just going to move over 4 units to the right. That's going to be one vertice. And then I'm going to go 4 units to the left to find my other vertice. I kind of want to move in here. So that's going to be my other vertice. Now the co-vertices is going to be on the minor axis, which is perpendicular to the major axis, and that's going to be square root of 7 units up. Now you might say, well, I don't know the square root of 7. Well, you know the square root of 4, which is 2, and the square root of 9, which is 3. So it's going to be somewhere between 2 and 3. So let's just estimate that here. 1, 2, 3. So let's just call that the co-vertice. And then 1, 2, 3. This will be my other co-vertice. Okay, so therefore now what I can do is I can kind of connect them to get a general shape. Ooh, that's bad. This is kind of hard with this thing. There you go. Not too bad. Oh, come on. Seriously? All right, let's try this again. Try it nice and slow. Yeah, looks something like that, right? Now, to go ahead and find my foci, remember a couple things on the foci. The foci lies on the major axis with the vertices. So the major axis contains the vertices as well as the center. So to find my foci, that's going to be, again, 3 units to the left and right of the center. Well, if I go 3 units to the right here, that's my foci. And then 3 units to the left, 1, 2, 3, will be this foci. So this one's kind of fairly easy enough that I can just, write down what my vertices are going to be. So my vertices, I'm just going to label for V, are going to be, now rather than writing them separately as negative 4, 0, and 4, 0, I'm just going to write them as plus or minus 4, 0. And again, I want to write them as the x-coordinate because they're moving left and right from the center. Where my co-vertices are, those are going up and down, so I'm going to write them adding and subtracting to the y-coordinate of my center, but it's 0, so it's just going to be there. And so that's going to be 0, comma, plus or minus square root of 7. Because you're going square root of 7 up and you're going square root of 7 down. And again, that's kind of where like that plus or minus comes from over there. Now, the foci, again, remember, are on the same axis as the vertices, which is the major axis. So again, those are going to be left and right, and that value is 3. So I'll just do plus or minus 3, 0. All right. So now, let's see if I can move this. No. See if I can move this down so I can see it. There we go. Perfect. Okay. So in this next one, you can see that, again, we have a squared is under x. So a squared, our larger denominator is under our x term, so therefore that's going to be, since our a squared is under our x, that's going to be our a squared. So let's just go ahead and maybe write this work over here so I can say, all right, a squared is equal to 25, so therefore a is equal to 5. B squared is equal to 16, so therefore b is equal to 4. And then if I wanted to find c squared, I'm just going to do the math here in my head. I'm going to do c squared is, well, a squared minus b squared, right? That was the formula I showed right there. So a squared minus b squared is 25 minus 16, so that's going to be 9. So c squared is equal to 9, and not always is it going to be like that simple, but a lot of times it is. C is going to equal 3. Now the center, remember, is the opposite, right? It's x minus h. Oh, it's right here. X minus h, y minus k. So it's x minus a negative 1 is the same thing as x plus 1. And this one still gets students, even though we did this whole unit on transformations and stuff, right? That's another way of writing x plus 1. But it's x minus h, so you can see that h is equal to negative 1. So my center in this case is going to be at negative 1, comma 2. Now, to go ahead and identify all these parts, what we're going to want to do here is we're going to want to graph this. Okay, so we go to negative 1, 2. And we say, that is my nice center. All right. Now, remember, since a squared is under the x, we're going to be going horizontally. So sometimes, especially when I'm off the center, I'll like to draw the major axis. So here is my major, here is my major axis. And then here is going to be my minor axis. And the reason why I like to do that is that's just like a reminder of where my vertices and my foci lie. The vertices and the foci lie on the major axis. And again, they're only a distance of, I'm going to move this down. There we go. Move me down over here. Okay. So remember that the vertices are a distance of A away from the center. So in this case, my A is 5 units away from the center. Well, again, since we're moving left to right, it's going to be 5 units away from negative 1. So to find my vertices, I don't want to use green. Let's use red again. So my vertices in this case are going to be negative 1 plus or minus 5, comma 2. Now, obviously, we can go ahead and simplify that, right? So we can do negative 1 plus 5 is going to be negative 4, comma 2. And negative 1 minus 5 would be a negative 6, comma 2. No, that's wrong. Negative 5, that's a positive 4. So now we could just go and plot those points, right? So we could do 1, 2, 3, 4. You could also count along the axis like I did in the last example. And this would be negative 6, 1, 2, 3, 4, 5, 6, comma 2. So there's my two vertices. Now remember the co-vertices, or let's do the foci next. So the foci, again, are going in the same direction, but they're going to be a value of c. So that's going to be -1 plus or minus 3, comma 2. And again, we could simplify that to -1 plus 3 is going to be 2, comma 2. And therefore, then -1 minus 3 would be a -4 minus 2, or comma 2. So we can just plot those points. There's my foci. And then -4, 1, 2, 3, 4. There's my foci. Now to find the co-vertices, though, again, we got to go on the minor axis. So that's going to be going up and down. We got to remember that distance, which is b, so that's going to be plus or minus 4. So it's just important to take your center. We're not going to add them to the x, the h coordinate, because that's going to move it left or right. We're going to add them to the k coordinate. So that's going to be -1, comma 2, plus or minus 4. And again, that plus or minus comes from like the taking the square root. You're going to have plus or minus 4 in that value. All right, so those coordinate points then are going to produce -1, comma 6 and -1, comma -2. And you'll see that those values, -1, comma 6, so 1, 2, 3, 4, 5, 6, and -1, -2, 1, 2. So those are my co-vertices. And then we can pick another color and go ahead and sketch it. And you can see that my ellipse is not perfect, but it is elongated horizontally. All right, so before I get to the next one, let me just cut a check in, see if you guys, thank you guys for going through this. Hey, let's see, Pokemon Go, Sophia, Harris, Varun, Butt. All right, it's geometry. Yes, it's actually called Analytic Geometry, but it's usually not taught very much in geometry, the course, at least in like a high school geometry. At least the high school geometry that I've taught. But it is analytic geometry, and is dealing with cross sections as far as taking a cone and slicing a cone in different ways. So that's where kind of conic sections that comes from. And so what we're doing right now is we're just looking at an ellipse, taking a cone and slicing it at an angle. And that's where you're going to get the shape of an ellipse. So Zed Master, this was my weakest unit ever. I hate this. Well, I am very sorry, Zed, that you had like such a bad experience with conic sections. It is like, I think it's one of those things that it's hard to kind of like grasp because there's like a lot of like moving parts. There's a lot of things going on, but I think it's also one of those things that's like right when if you are able to get over the hump, then everything kind of connects, because everything we're doing from parabolas, ellipses to hyperbolas, they're all like connected, and the processes are all connected. So once you can start to understand one, I think the pieces will start to come together. But I totally get there's so many things to remember, like A, B, C, all these different formulas, asymptotes, vertex, focus, directrix, vertices. There's like so many things going on. So I totally get it. But one of those things just comes into is like, practicing and just kind of working basic, step by step. And you know what, I actually do have a step-by-step guide as far as how to graph all the conic sections, as far as how to write the conic sections. So, I keep on wanting to post in the Facebook group, and I keep on like just putting it off for whatever reason. If anybody is watching this and wants to have access to my step-by-step kind of cheat sheet that I created, please go to my support groups in the Facebook and be like, hey, Mr. McLogan, you said you're going to give this thing out away. Can you please give us the link to go ahead and get signed up for this? Because I have it available. I spent probably a couple hours creating it. And, I had an editor go ahead and, edit it, and I had somebody create it, and it cost me money to make this thing. And I still haven't like sent it out to give it. I've gave it to a couple of my students that were like absent, but that's like it. Like I haven't given it to the people that I created it for were mostly like my online students, not so much my students inside the classroom. So, if anybody's interested, just go to my Facebook group. Again, the links are down below, and just reach out to me and say, hey, you said you're going to give this away. Let me see it. But anyways, man, I need to go to sleep now. Great love. Hey, Harris, thanks for staying up, man. Get some sleep. You can always watch the replay. And again, if you guys type in, hashtag, I'll just type that in on my channel. But if you guys need anything with conics, if you guys type in hashtag conics, on YouTube, then I have a whole bunch. Sometimes you need to type my last name because they're not really as search friendly. But if you guys type in any of that stuff on the YouTube search, you're going to pull up all of my playlists. And I didn't even create that many playlists. I didn't even create that many videos this year just because I have so much content, I didn't want to like overload all of my playlists. But anyways, let's go and finish this up because this is one where I think it gets a lot of tricky for a lot of students. So I really want to do this one. And then I'll tackle I think I got 3 more problems. Yeah. So we're not really going to do that quick of a live stream. Might take us a little bit, but if you're still with us, awesome. Let's get forward. Let's move on. All right. So on a problem like this, what we notice is we're not in our standard form anymore, right? It's not in this form. We don't have any binomial squared. So we have to create our binomial squared, which is the process called completing the square. So to do that, first thing I need to do is group the x's and the y's, and then I'm going to get this constant over to the right side by adding a 23. Now you don't have to do this, but I think it's just kind of one of those like housekeeping things, like let's get the x's together, the y's together, and everything else to the other side. So if I rearrange this, I'm going to have 9x squared minus 18x plus 4y squared plus 8y equals 23. Okay. Now what I can do is I can group the x's and I can group the y's. And what this allows me to do is within each grouping, I'm now going to want to complete the square, meaning I'm going to want to create a binomial squared. But before I can create a binomial square, before I can complete the square, I cannot have a coefficient of 1 when completing the square. So I'm going to have to factor out a 9. And this is what I do in class sometimes with my markers. I do all this color coordination. So when I factor out a 9, that's a different blue. I don't want that. I want to keep it similar because I have that ADD thing going on for that. So when I factor out a 9, I'm left with x squared minus 2x. Let's go back to the orange. Sorry, it's going to take me a little bit longer to do this, but I really like doing like the different colors sometimes for the visual effect, especially for a problem like this. Here I'm going to factor out a 4. So when I factor out a 4, I'm now left with a y squared plus 2y equals 23. All right. So now what I've done is I've factored out the terms. So now both of my variables have coefficients of 1. So now what I can do is go ahead and complete the square. And if you guys remember creating the squares, we're finding the constant c that makes both of these blue expressions a perfect square trinomial. And to do that, all you got to do is take b divided by 2 and square it. Now remember, b comes from the standard form of a quadratic equation, ax squared plus bx plus c. Now, we're not really talking about quadratic equations anymore, but we can see that we kind of almost have a quadratic form here. So we have the b value. We just need to figure out what c is. So we're going to take negative 2 divided by 2 and square it, and that equals 1. In this case, we're going to take 2 divided by 2, square it, and that equals 1. So now what we're going to do, now this is where students start to make their mistakes. And I got a lot of color coordination going on. So I'm going to have 9 times, going back to the blue, x squared minus 2x, going to the red, I'm going to add the 1 inside the parentheses. Add the 1, go back to the orange, go back to the blue, plus 4 times, now the y squared plus 2y. Now I'm going to add this 1 inside the parentheses. Then we have my orange. Jeez, oh man, that's just so much work. But I think it's helpful because now what you guys can see is I changed this equation. So technically from going from here to here, I didn't do anything that affected the value of the left side of the equation. I just factoring out numbers. That's fine. But now that I've added these values, I got to add them to the right side. So we got to be careful though, because you're not really adding a 1. When I add a 1 to this right side, because you add a 1 to the left side, you got to add 1 to the right side. I'm not really adding a 1. I'm adding a 1 that by distributive property is being multiplied by 9. So that means I got to multiply this equation by 9. Then I added a 1 over here. So now but this 1 is not really being added by 1. This is being a 1 by being multiplied by 4. So I got to multiply this 1 by a 4. And it turns in it's like, oh my God, there's just so many things going on here. But I think what we'll see is this is not going to be as bad as we are looking at. Okay, so the nice thing about completing the square, though, is we have created we have created perfect square trinomials, meaning the factors are binomials that are exactly the same, so we can just write them as like squared. So if you wanted to factor them long form, you definitely could. But I'm just going to go back to a solid color now. But x squared minus 2x plus 1 is basically saying what two numbers multiply to give you 1, add to give you negative 2. And we can see here that that can be rewritten as x minus 1 squared plus 4 times this can be rewritten as y plus 1 squared equals, now let's do this. We got 23 plus 9 is going to be 32, plus 4 is going to be 36. Back to her. So we have 36. Now, this is not in standard form. Standard form, way up here, was when this expression was equal to 1. So I got to get this expression equal to 1. So what I'm going to do is I'm going to divide by a 36 on both sides. So when I divide by 36 on both sides, this 36 has to divide into both these expressions. You got to make sure you divide that in there. And now, finally, I get 9 over 36, which is equivalent to 1/4. So I can rewrite this as x minus 1 squared over 4. And then I have 4 over 36, which is equivalent to 1/9. So therefore, I have y plus 1 squared over 9. And then equals 1. And this brings us to a brand new form, because in our previous examples, the a squared is always larger than b squared, and a squared was always under the x. So that means everything, the vertices and the foci were, horizontal. Well, now we have a squared under the y. So, just write the equation here real quick. It looks like this. X minus h squared over b squared, which is the smaller term, plus y minus k squared over a squared equals 1. So again, a squared is always larger than b squared. But if a squared is under the y, now we're going to have a vertical major axis, which we'll kind of look at here in a second. So anyways, let's go ahead and find our important piece of information, though, just like we did before. Again, the center is unchanged. It's still h comma k. So in this case, my center is going to be 1 comma negative 1. My a squared, again, is going to be, in this case, is going to be 9. So a squared is equal to 9. So therefore, a is equal to 3. B squared is equal to 4. So b is equal to 2. Remember c squared, let's see, a is equal to a squared minus b squared, right? So therefore, a squared minus b squared, that's 9 minus 4. So therefore, c squared is equal to 5. So c is equal to the square root of 5. And again, I'm not doing the plus or minus. I'm just keeping it as the regular value here. I'll get to questions and comments here, guys. Once I finish this, I'll take a break after this problem, again, to kind of smooth my way over. So now let's go ahead and plot the information so we can write the forms. Let's choose a different color. I wonder how green and pink work. So the center is at 1 comma negative 1. And now again, remember, let's do these major axes. Now my major axis is vertical, right? And my minor axis, let's do a yellow, is horizontal. That yellow is hard on the eyes. Now, but the important thing, guys, is determining, since my major axis is vertical, that's where that's where I'm going to be going up and down to find my vertices. So from here, I'm going to go up 3, which is 1, 1, 2, 3. Vertice, and then down 3. 1, 2, 3. Okay. Now again, you can add or subtract these however you want, but I think, I kind of have enough information. I could probably do these just in my head by knowing, okay, my vertices, I'm going up 3, so that's going to be, my x coordinate is remaining the same. My y coordinate is what I'm going up and down from, right? So my vertices is going to be 1 comma. So if I'm going up from negative 3, that's going to be at 2, which you guys can see on the graph. And if I'm going down, that's going to be at negative 4, which again, you guys can see on the graph. So you can count them as you're getting used to it. You're still learning, or you could just do like take the center and then do plus or minus a, which I did in the last example. Let's do the foci, because the foci lie on the same axis. Sorry about that. Whoa. So since the foci lie on the same axis, my C is going to be 5. So I'm just going to write this as 1, comma. Now to save a little time, I'm not going to do the plus or minus. Yeah, let's just do it. Why not? So it's plus square root of 5, and then it's 1, comma, negative 1 minus the square root of 5. Okay, or I prefer just to write plus or minus. It saves time. But anyways, let's go ahead and now do the co-vertices. Sorry, I cannot write at all with this tablet pen. Now the co-vertices are going to be along the minor axis. Now again, let's just estimate the square root of 5. Let's see, square root of 4 is 2, so it's going to be between 2 and 3. So 1, 2, somewhere right around there. Oops, I don't know why I didn't do that. There you go. And then down to 2, 1, 2, and then 3. Okay, so the co-vertices are going to be going left and right from my center. And they're going to be going left and right distance of 2. So basically what I'm doing is I'm taking the y value and I'm going to, sorry, here's the x value, I'm sorry, of the center. I'm going to subtract 2, which will take it to negative 1. I'm going to add 2, which will take it to 3. So you could look at the graph, go left 2, and then go right 2. You know, either way, whatever works. I like to do the graph so I can visually see it, but sometimes you're not going to always have easy, nice numbers that are going to be on the graph. So therefore, you're going to be left with, well, why don't we just subtract and doing this? So the y-coordinate remains the same, so we're going left 2, so that's going to be at negative 1, comma, negative 1. And then going right 2 is going to be at 3, comma, negative 1. All right, so I'm going to get into graphing, but let me just go and check, see what you guys are still with me, hopefully, because now we're going to get into the graphing, not that way, this way, we'll call it up. So here's some of the problems we're going to look into is just to write the equation. I don't think I'm going to be able to get too much Q&A though, as I was hoping. I was doing 2 homework problems and it's already taking me 30 minutes, but let me just go and see what you got in there. Paish, I'm sorry, I just probably badgered your name, but let me just kind of read what you got here. 3 years ago, his age and 2/3 of the sister's age added up to what is the sister's age? Completing the square, Zachary. Yeah, Paish, I would have to go and take a look at that and add that up. So there's the guy's age, and his age is 3 years younger than his sister. 3 years ago, his age and 2/3 of his sister's age added up to equal 12. That is just a bad, like, why would you, like, I don't know. Those are crazy problems. Yeah, I'd have to think about it, but to be honest with you, I'm just not going to have time to really get into that or to really break it down. That's probably one of those that after I've done a day of teaching and then I've been going live, my brain probably is going to hurt just even like reading, thinking that, just like kind of like you guys. So my best thing is at least I can give you guys some, I'm not going to have time to go through it, but Payush, I would definitely recommend, setting variables for the age, like, so a guy's age and then his sister's age, and then using the language in the problem to create an equation and expressions to represent their age, and then go ahead and solve for each of them. So since you're going to have 2 variables, you're going to want at least 2 different equations. So that's at least where I would start with that one. But I don't have time to go through that, or I don't think my mental capacity right now on a Friday after teaching is going to be able to allow me to like focus in on that for you. Sorry about that. So Justin, just period cos, there's another way to do this without completing the square. Well, I mean, I guess you could. No, I'm not really sure if there's really another way that's going to be. I mean, I'm not really aware of, no, as far as, because I mean, we want to create binomial squared. So I'm not aware of a more efficient method to allow us to create binomial squared rather than completing the square. So as far as what I am thinking of, at least on the top of my head right now, I'm not aware. There could be one that I'm totally like missing or not thinking of, but I'm not off the top of my head. I can't think of anything. And JC, dude, you have helped me so much. Well, thanks, JC. Happy to be able to help you guys out. All right, guys, let's try to wrap this up. So what I'm going to do now is go ahead and plot it. So with writing the equation, and again, guys, I appreciate you, reaching out and asking things. I apologize. I said I was going to do some Q&A, but I'm just not really going to have the time to get into much Q&A today, but I will plan on, as far as hopefully school can slow down a little bit for me, try to go live a little bit more often, and so therefore I can answer some more of your questions. But anyways, let's finish. So now what we're doing is we're given some information. And when given the information, what I like to do is sketch the information so we can kind of visually see what's going on. So we have a foci at 2, 0 and a negative 2, 0. Okay? Those are our two foci. And then it says the major axis length is 10. Now, so let's kind of go back up to the equation here and take a look at this, or at least like our last problem. Let's do one that's horizontal that we looked at. Okay, so notice when we're looking at like the center, notice how the center is in between the two foci. So if we can find the two foci, the center is going to be right in between the two foci. So that's important, point number one. Another point is the distance from the center to the vertice is A. Well, if you look at from vertice to vertice then is going to be 2A. And again, remember the vertices and the foci lie on the major axis. So they said our major axis length is 10. That's basically telling us from vertice to vertice is 10. So if I just wanted to find the distance from the center to the vertice, that's half of that length, which would be 5. So based on this information, if I have my foci here, which is right here, and my other foci is right here, and I know the center is right in between them, I can now find my center, which is at 0, 0. Right? If the major axis length is 10, remember the major axis length is from vertice to vertice. So from vertice to vertice is 2A. So the major axis length has a value of 2A. So if I say 2A is equal to 10, well then A is equal to 5. Right? So from the center, I can go to the right 5 and to the left 5 to find my two vertices. But I'm not really too concerned about that. I just want to write the equation. So now I'm kind of like working backwards. If A is equal to 5, then A squared is equal to 25. If C is equal to 2, then C squared is equal to 4. And now the only thing I need to write my equation, I need to have H, K, and A and B. Well, I don't have B. So let's go ahead and remember it's A squared minus B squared equals C squared. Okay? So I could rewrite this to solve for B as A squared minus C squared equals B squared. So therefore, I can do this and I can see that B, or B squared, is going to equal 21. Right? A squared is 25 minus C squared is 4, so 21 equals B squared. Now, to write the equation, I notice that my foci are on the horizontal major axis. That means my A squared is going to be under my X. So therefore, I write this as my center. So that's going to be X minus 0, so I don't really need parentheses. So I'm just going to write X squared divided by my A squared, which is 25, plus Y squared over my B squared, which is 21, and that's going to equal 1. And there you go. All right, so the next one, again, talking about the major axis length, which is 2A. So 6 is equal to 2A. And it says that's on the y-axis. That means that's going to be vertical. So that means automatically I know that my A squared, which in this case is going to be 9, is going to be under the y. And then it says the minor axis length is 4. Well, that's going to be equal to 2B. Because minor axis length is from co-vertice to co-vertice. Well, from center to co-vertice is B. So from co-vertice to co-vertice is going to be 2B. So let's just go and do this. So we have 6 equals 2A divided by 2 divided by 2. So 3 equals A. And then here I have 4 equals 2B divided by 2 divided by 2. 2 is equal to B. Now, hold on a second. 21 on the y-axis, major axis length of 4. It actually doesn't even tell us what the on the y-axis. And it doesn't actually give us enough information for us to be able to figure out where it is. I was thinking it would tell us where the center is. But I guess let's just assume that the center is at 0, 0. So since that's my A, right? Okay. So since we already know A and we already know B, we can figure out A squared, which is 9, and B squared, which would be 4. So assuming that they wanted us the origin to be at 0, 0, I apologize, I didn't add that in there. We can write this again as like x squared plus y squared. Now again, remember the major axis is along the y squared, so I'm going to put my A squared in this case under the y and my B squared under the x. And there you go. All right, ladies and gentlemen, last one. Hey, YouTube addictions, you're smart. Thank you. Well, I wouldn't really consider myself that smart. I've just done a lot of practice, and obviously teaching is, one of those things that I go ahead and do. So see you later, Justin. Thanks for stopping in, man, and wish you the best of luck as finishing off your year. All right, last one we got here, guys. Major axis endpoints, 3, -7 and 3, 3. Minor axis length 6. So let's go and plot the major axis endpoints because we want to see, is this going to be a vertical or horizontal? So I go 1, 2, 3 up to -7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go over 3, 1, 2, 3, over 3. So there's my vertices. So just by looking at this information, you guys can see that my vertices are going to be vertical, right? And then also I know that my center is going to be right in between my two vertices. So we can just go and count this as 1, 2, 3, or we can say it's 10, right? So the halfway distance is going to be 5. So 1, 2, 3, 4, 5. And again, if you just want to check, you can get, check 1, 2, 3, 4. That should be at 5. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Right. So that point. There you go. So now just by verifying that information, we can see that this is going to be my center, which is at the point 3, -2. Now, if you had like some really hard numbers to work with, like some fractions or radicals, you could use the midpoint formula to find the midpoint. But the main important thing is we see that the major axis is vertical. That means my a squared is going to be under the y. Now, I could, again, just count, or I could use like the distance formula if I needed to find the distance of a, which is distance from the center to your vertice, which is just going to be 1, 2, 3, 4, 5. So I can say a is equal to 5. Let's just do a squared then real quick, which is 25. Okay, minor axis length is 6. Remember, the minor axis is from co-vertice to co-vertice. So therefore, distance from center co-vertice is b. So this 4 is equal to 2b. So therefore, b is equal 3 as I divide by 2. So now, ladies and gentlemen, we have the center, which is your h and your k, and we have the values of a and b. So that's everything we need to know. So we can do x minus 3, because remember, it's always x minus h squared. AB squared needs to be under the x, which is 9, because remember, it's a vertical transverse axis. And that's going to be plus y minus a -2 is going to be y plus 2 squared over a squared, which in this case is 25, equals 1. Okay, boom. So there you go, ladies and gentlemen. Thank you so much for topping in. I hope I helped you out with your conic sections. If you are watching this on a if you're not watching this live and you're watching the recorded version, if you do have any questions on what I have covered, make sure you can always go back to any of my playlists on conic sections, or you can always comment below and ask me. Or if you're interested in a little bit more assistance with pre-calculus or algebra 2, I do have 2 Facebook support groups that I am offering to students as a way to kind of communicate and get help with their maths over on Facebook. So those 2 links are down below, but I hope you guys enjoy the rest of your day, weekend, night, morning, whenever you are watching this. And so take care, guys. Bye.